In this video we are going to look at this problem which says that the resistance of two conductors in series is 40 ohms and their resistance becomes 7.5 when connected in parallel. Now we have to find the resistance of the individual conductors. Now this question, we should keep in mind that we are given the two cases. The first case we have the series, and then the other one is parallel. So to solve the problem, we start first with series, and if we are finding the sum of the sum of resistance of individual conductors, if they are in series, in this case there are two. Let's call the first resistor to be R1 and the second one to be R2. So we are told that the sum of these two should be equal to 40 ohms. To visualize that, we know in series we have a resistor there and then another resistor. So this is R1, this is R2. That is in series. In parallel, we can visualize it in this way. We have one resistor there and the other resistor is here. So this is R1, this is R2. So we have two resistors. You can see in series we have two of them. In parallel there are also two. So we want to find the resistance of the individual conductors. Now in parallel we know it's R1 times R2 over the sum of the two. And we are told their resistance becomes 7.5. We can equate that to 7.5. Now let's call the first equation to be equation 1. Now what is also interesting here, we can rewrite this R1 R2 over, let's say, equal to 7.5, where we have R1 plus R2. We have it here already. We have R1 plus R2 equals to 40. So here we just write 40 because that is what is equal to R1 plus R2. Now what we can do here, we can now, I think I need to use a black pen. We can now multiply both sides by 40. Both sides by 40. So that this 40 here and this 40 can cancel. So that we can only remain, let me continue with the black, R1, R2 equals to 7.5 times 40 equals to 300. We have 300 here. Now here we can now rewrite, let's write R2 in terms of R1. Then we are going to have 300 over R1. So here we need to come up with a quadratic equation. We go back from equation 1. Let me rewrite it. R1 plus R2 equals to 40. Now we now have to take what is equal to R2 and then replace it in there. the place of R2. Then we are going to have, okay, this is our equation 2. I forgot to mention that. Then we have our R1 plus, instead of writing R2, we write what is equal to R2, which is 300 over R1 equals to 40. We multiply throughout by R1, so that here we can have R1 square plus, here if we multiply the fraction by R1, we only have 300 equals to 40 R1. We can now rearrange here so that we can have R1 square. We bring this to the other side, becomes negative 40 R1 plus 300 equals to 0. So that is the quadratic equation that we have there. Now, for us to solve for R1, keep in mind that we are finding the resistance of the two conductors, which we represent by R1 and then R2. In this case, we will now want to solve for R1, and then later we are going to use this equation to solve for R2. Now, solving for R1 here, you can either use completing square, or you can use factorization, or you can use the quadratic formula. Let me use the quadratic formula here. R1 equals to minus b plus minus square root of b square minus 4ac, which is the discriminant, over 2a. In this quadratic equation, our a is equal to 1. Our b is equal to negative 40. And then our c is equal to 300. We can now substitute that. The negative 40 and the negative becomes positive. Plus minus square root of 40, not square root but square of 40, minus 4 times 1, and then times 300, 2 times 1. Here we have 40 plus minus, let's work out the discriminant there. We have, okay, what is under the square root is, just do it, 40 square minus 4 times 1 times 300. We are getting 20. So we have 20 over 2. Now here there are two things. We write 40 plus 20 over 2, or 40 minus 20 over 2. 40 plus 20 is 60. 60 divided by 2, we get 30. Or 40 minus 20, we get 20. 20 divided by 2, we get 10. So that is our R1. So our R1 is either 30 or 10. Now to solve for R2, we are going to use equation 2. We have R2 equals to 300 over R1. Now our R2 is equal to 300 over, if our R1 is 30, we can write 30 here, saying our R1 here is 30. This will cancel, and then our R2 will be 10. Or if our if our R1 is 10, if our R1 is 10, then our R2 is 30. Therefore, we can now write that the individual resistance is equal to 30 and 10, or 10 and 30. That is the final answer. If you are new to this channel and you are doing maybe electrical engineering or whatever course that you are doing which involves mathematics, please do subscribe to the channel so that you can follow the videos that I keep uploading every week. Please like and share the video with others.